have already discussed in the beginning that we have two types of signal. One is called analog signal, and second is called the digital signal. The computers work with the digital signals. All the informations are represented by the digital signals. So basically in digital signal you have only two states, high or low. In between you don't have anything. But with analog signal there is continuity of these signals. And we will give you appropriate example later on. Let's talk about this is the example. Just see this graph. This graph shows you the analog signals now. Means there is always continuity. It's not a discrete type, right? There is a high or the low. But again there is some what we call them, some signal presence is everywhere. You have like for example this watch. Now this watch is again, this is what we call the analog, because here is always you have a digital clock and you have an analog clock. So this is basically analog, because always you can between the 2 minutes, not only it is showing you only minutes or second, but between the 2 minutes also there is some various points they are showing you. But when you have a digital clock, they are showing you only seconds or minutes and so on. But here always between the 2 seconds, always between 2 minutes, you have some other points that is also being present. So you have a digital clock and you have a analog clock also. So this way one has to try to understand the whole system now. So this is basically this way analog signals are presented now. Now let's go to the actual definition of what exactly we understand by the analog signals now. So in analog signal, the first important characteristic is the signal is continuous. The always continuity is maintained. Analog signals are basically represented by the sine wave. The wave which we have shown you is what we call them the sine wave. The analog signal are what we encounter in every day of life. Always we basically, most of the time we encounter with only analog signal, not the digital signal. Only within the computer we work with the digital signal, which is also hidden from us. A speech, when we are talking to somebody on the telephone lines, these are basically analog signals, right, which varies in amplitude and the frequency, right. So the amplitude basically refers to the what we call the volume, and frequency is basically referring to the pitch. So always this is called your analog signal. So this is a good example of analog signal, that whenever we are talking on telephone, we are basically the system is using as an analog signal. And now, so what are the three basic components of an analog signals, or the terms or terminology? One is what we call them frequency, the second is what we call them amplitude, and third one is called hertz. Let's have some definition. The number of times a cycle occurs in a given time period. How many times your cycle is changing per second, and that is called the frequency. So more frequency, for example, megahertz, let's say 5 megahertz has a more frequency than let's say 2 megahertz, and so on, because the signal frequency is changing very fast there. Then we have a wave amplitude, means the height of the wave, the voltage level of the signal, that is called the amplitude. And hertz is basically number of times a wave cycles occurs in 1 second. So these are the important components of an analog signal. So at a data communications, we have to understand all these things very much. Even when you buy a computer, the marketing mind comes to you that the processor is basically the capacity of processor, or the bandwidth of a processor, it comes into 500 megahertz. That is the way they refer to so this has become what we call them the good marketing terms also. The megahertz is something not used only just as inside the computer, but also we talk as that we show the speed of the machines also. So this refers to the clock cycles. Now talk about, this is the digital signal now. Just in this case, what we are talking about, all the informations in digital signal is represented in form of 0 and 1. 0 is basically represented as a low voltage, and the 1 is represented by the high voltage. It could be between 3 to 5 voltage, and it is less than 3. So basically might be, so let's say for example, this might be a character A, for example. Then the character A might have some sequence of 1s and 0. Then actually it will be represented by in this form. This is 0, this is 1. Again there are 2 zeros, so we have a 2, and so on. So this way we are trying to refer to this bit 0 is for this one. So this way digital signal is represented. It bit in between, right? In between 0 and 1 in between this one and this one, no other information is there, no other continuity there. So it will be either high or low, either signal will be present or the signal will be absent. This way, now sometimes people ask why we have gone for the digital signal, why we have only two states. If we had gone for different number of voltage level, then the circuitry for the computer could have been much more complicated and much more costly. So the digital signal, where we work with the binary numbers, only with the 0 and 1, is much easier to represent it and to design a circuitry also. If you have a more voltage level to interpret the signal, then signal will be much more complicated and cost will also increase proportionally. So now, so the digital signal is basically, let me summarize what we have discussed about the digital signal. The digital signal normally comprise only two states. They are expressed as on or off or 1 or 0 and so on. So basically now, as we have a frequency, we have a amplitude as a basic terminology for analog signal, same way we have some important notations or terms in the digital signal. We call it bit. The basic unit of information is called bit, either 1 or 0. If you have 2 1 1, if you have 1 1, then we are talking about 2 bits. If you have 1 1 0, we are talking about basically 3 bits now. Each character, for example, my name is ABC, means I have a 3 character. Each character is basically represented by a 8-bit character. Now 8 bit. Now 1 bit is basically used for error correction purpose, and 7 bit is basically used for representing a character. So with ASCII coding system, which we normally use in computer system, the maximum number of different characters can be represented is called 2 to power 7. Means maximum you have a 128 characters you can represent, not more than that, because to represent each character you require the standard is 8 bits, where 1 bit is used for what we call them error correcting bits. So only 7 bits have used. So if we have more characters to represent, then it will not be represented with ASCII coding system. So most of the computers, personal computers, they follow the ASCII coding system for representing the characters. So the whatever character form, the whatever bits combination you have on this machine for on other machine also we have the same combination, because same standard is being followed. Otherwise your program will be not be portable, because bit should be interpreted by a same bit combination on that machine. If there is some difference, again your program will not work on that machine. So that part is you must understand. So bit is the smallest unit of informations. Now the byte is basically again combination of 8 bits is called 1 byte, right? So basically to represent one character you require 1 byte. So that is the minimum number of bits are required for representing a single characters. Now then we have a KB, kilobytes, then we have a MB, megabytes, gigabytes and so on. So these are the important digital terms, or the way we represent the informations within the computers now. But you must understand that we basically work in computers, always we work with these are for users to interpret, but inside the computers we work only with the 2 signals, the high signals and the low signals. Now now how data is, now we are talking about some new things, the data transmissions mode, how data is being transmitted or information is being transmitted between the 2 machines, or right, between the senders and the receiver. 3 ways the data can be transmitted, what we call them the simplex, the half duplex and the full duplex. So the 3 basic approach which is being used for exchange of data between the receiver and the sender is what we call them the simplex, the half duplex and the full duplex. Let's see what is the simplex. This is the diagram for the simplex. Means basically what we have, one way only, the signal is basically transmitted in one direction only. For example, radio or what we have a television is basically being broadcast from the studio, and usually not basically doing any sending the reply back and so on. So basically if the data communication is taking place in one way, like radio broadcast, television broadcast, it is basically one way information is being flown. So we say the simplex channel operations. Now again, important characteristics of a simplex channel is it only transmits in one directions, rarely used in data communication. We hardly use this type of things in data communications. Receiving signal from the radio station and so on. This is one of the example I gave you. TV broadcasting is another example. The sending station has only one transmitter, the receiving station has only one receiver, right? Because receiver is simply receiving, not sending the data back, and transmitter is simply sending the data, not getting the reply from the if you have this type of arrangement, then what we say, that is it is a simplex type of channel now. So what is the real advantage? Very simplicity, right? The designing of a simplex channel is much more easier. Now let's talk about the half duplex operations now. Now you have to take more examples to understand that where else we are using simplex type of channel now. Now let's move to what we call them half duplex operation. Just say this diagram is basically two-way but not at the same time. The signal can travel both ways, but basically it can at a time in only one direction. When we are talking to somebody on the telephone lines, it is basically any time both of them can talk, whether they understand or not, that is something different, but that is the example of a full duplex channel when the transmission is taking place in both the directions at the same time. But if the transmission is can take place in both the directions, but only one at a time, what we call them is half duplex. For example, you have seen some security people having some walkie-talkie. So in this case, it's basically example of a half duplex. Only one person can talk at a time. But if that happens with the telephone system, or what will is basically both are talking at the same time. So what we have now, let's try to understand the characteristics of half duplex. Data may travel in both directions, but only one direction at a time. It is more difficult, more costly than the simplex, but again it has some other flexibility. Provides non-simultaneous two-way communications. Computers use control signal to negotiate when to send. There must be, this is what we will be trying to understand, the protocol. This role of protocol is to control the operations between. So when one is sending, other has to wait for it. When second one is sending, the first one has to wait for it, and so on. Right? Now the last one, the time it takes to switch between sending and receiving is called turnaround time. So this is the information about the half duplex. So some protocol supports simplex channel only, some protocol supports half duplex only, most of the protocols today they support both, what we call them full duplex. So we have a certain protocol which in what we call them data link layer protocol called SDLC, they support both full duplex channel, but they also support half duplex channel. So depending upon your need, you can program the channel to transmit both ways or one way at a time. Now finally, again what we have a full duplex, and I have given you a small example. The telephone system is example of full duplex. Data can transmit both ways, so they have a channel in data can flow in both ways now. And to understand full duplex channel, you try to examine what we call the data link layer. We discussed various other protocol which basically supports full duplex operations. Now what are the features of the full duplex is that it completes two-way simultaneous transmission, but faster than the half duplex communications, because no turnaround time is needed. Both can transmit, which is much more faster, and most of the protocols support TCP/IP support this type of activity. Both senders and receivers can send data at the same time. Now basically let's talk about various ways I can transmit my data. Well, basically what I discuss is mode, data transmission mode, and that was a full duplex, half duplex, and what we call them simplex now. Now I can also transmit. Now you will know that each character is represented by number of bits, and if we are following the ASCII coding system, then we are having the 8 bit to represent a one character now. Now what we are talking about, how they are basically transmitted. So here is the two different ways data can be transmitted. One is what we call them serial data transmissions, and second is called parallel data transmissions. So now what is happening in serial data transmission is that the data is being transmitted, or character is being transmitted bit by bit. So now for example, if I have let's say for example, this is the data you see, this data is 1001100. So if I have to transmit this data, first this will be transmitted, then this will be transmitted, then this will be transmitted, and so on. This is a 1 bit combination for representing one character. This is called least significant bit, and this is called most significant bit. So when data transmission in serial fashion start from the least significant bit, that is 1, and then only the last bit will be transmitted, that is called most significant. So the point is, what I am trying to explain is that that if we are transmitting bit by bit, starting from the least significant bit, is called serial data transmission. This is also used in the computer network. Now we have a what we call them, another is what we call them parallel transmissions. Let's try to talk about the anyway. So we already all explained now. Each bit is sent over a single wire, one after the another. But what happens in the parallel transmission? Just say in this case, first I am transmitting bit 0, bit 1, bit 2, bit 3. This is what happens if we are transmitting one after another, then it is called serial transmission. But if I am transmitting one character in one go, then it means this is called parallel transmission. It means I am transmitting one character. It means to transmit the parallel or to support parallel data transmission, you must have so many lines available with it, right? Just for that, it will deviate from it. You must see sometimes when you are examining, if you are opening the computer system, you have one chip called microprocessor chip. And now in microprocessor chip, you have a number of pins. Most of the microprocessor of older generation had a 40 pins now. Now again, they have few pins are reserved for the address lines, few pins are reserved for the data lines, and so on. So now, if you are, suppose that if I say that it is 16 bit, suppose that sometimes you say the bandwidth of a machine, or let's say what we call them, yes, bandwidth of machine is 16 bit machine. It means 16 bit of data can be processed at one go. It means they must have 16 bit of lines for processing the data. This is what we are talking about, that when we have a parallel transmission, means all the bits of the single character will be transmitted in one go, right? So if you have ASCII coding system which requires 8 bits, it means 8 lines must work in parallel. Now so basically what exactly it means, parallel data transmission? It refers to transmission one or more bytes at a time. Right now we are talking about 1 byte at a time, means one character at a time, right? It could be 2 bytes at a time, it could be 4 bytes at a time, depends upon the machine. So I told you earlier that when we say, sometimes when I buy the microprocessor, for example, most of the microprocessors today is in Pentium category, they are called 32-bit microprocessor. What exactly we understand by this one? What is 32-bit microprocessor? It means we say that 32-bit refers to word length of a machine. I just repeat once again, when I say 32-bit machine, it means that it refers to word length of a machine. It means that 32-bit machine, at one go, it can process 4 bytes of data. Means that 32-bit machine is twice faster than 16-bit machine. I mean, of course, I will not directly that way related, but definitely much more faster than the 16-bit machine. So in 32-bit machine, it means 32-bit lines are there for data transmission. In 16-bit machine, at least 16 bits are there for the data transmission. So this is basically this way we try to understand by the parallel data transmission. How many bits are parallel being transmitted between the sender and the receiver? And now each bit you must have a separate wire. Now the two important techniques are there, the synchronous and asynchronous transmissions. Now what exactly we are talking about is like this. Now is something you must be a little bit aware of. For example, if I am talking to somebody on the telephone lines, it is basically what we will call them, we can just try to understand. I will give you another example to understand, and that telephone example, that will be your exercise now. In virtual campus mode, where we offer two programs, what we call them BIT and ADIT, we provide two types of counseling support. One is what we call them asynchronous mode of counseling, and second is called synchronous mode of counseling. So when you are sending if you have certain doubts, you send your email and then we try to reply it. That is called asynchronous mode, because both the senders and the receiver, sender as a student and receiver as a faculty of School of Computer Science, not are bound by particular time factor, that when you are sending, I am also waiting for your replies and waiting for your email and so on. So when time is not factor, they are not basically synchronized at all. This is called asynchronous mode. But when we do the chat session, then basically what we are talking about synchronous mode of transmission. Means that both has to agree by the time, that same time you will be there, go to our site, download your chat server and so on. This is called synchronous serial transmission. So the same analogy can be given for synchronous serial transmissions and asynchronous serial transmissions. And accordingly, protocol must be able to support for the synchronous as well as synchronous transmission. Now talk about what is the synchronous serial transmission. One of the important characteristics is that the transmission of data in which both stations are synchronized. Right? Number one, the codes are sent from the transmitting station to the receiving station to establish the synchronization. When we examine the data link layer, we have certain type of encoding techniques, what we'll call them Manchester encoding and differential Manchester encoding. We have made some reference to it, but the point is like this, that before sending the data, they have to be fully synchronized. What exactly by synchronizations means, let's try to understand. That if I am speaking very fast and you are basically very slow, then half of the information will not be understood. So by synchronizations means that both sender and receiver must follow the same speed, same protocol, and also that they must be able to interpret the bit in precise time. For example, the bit duration is 1 millisecond. It means that within 1 millisecond, the receiver must be able to understand that this is the bit 1 or this is the bit 0 or this is the bit for the data and this is the bit for the control signal and so on. So that way they have to fully synchronize now. So now the communication protocol that controls the asynchronous transmissions, SDLC. So basically we have two protocols called SDLC and SDLC. Both support synchronous mode of transmissions. Both have to be. So when data in synchronous mode, first bits of data is transmitted for synchronizing the receiver, and then only data takes place between the senders and the receiver. So some signals, what we call them control signals, are basically transmitted so that the receiver must be fully synchronized, must be able to fully interpret the signals. But when we try to understand the data link layer protocol of IEEE series, they will talk about what we call the Manchester encoding. Within the signal itself, there is a message for synchronization. They don't have a separate message for synchronization. The signal bit itself will able to give you information for synchronizing it. Anyway, the point at this stage is that there are two protocols called SDLC and SDLC which supports the synchronous protocols. By synchronizing means the speed, the duration of the signal and so on. So this is basically, you know, that this is the packet for the synchronous will be somehow what we call them apart from the data, they have some informations called header and data and so on. So right now that is not important. Point is, before sending the data, some informations will be transmitted that is meant for the synchronization's purpose. Now what we have asynchronous serial transmissions, the transmission of data in which each character is what we call them is a self-contained unit with its own start and stop bits now. So there is they send before sending one character, they send a starting of the character, then a stop of the signal and so on. So here is that is not that way what we discussed in the synchronous mode. Now here means basically what I am talking about here is that in asynchronous mode the transmission is entirely of different kind. Before sending the one character, they send the starting of that character and then a stopping of that character. When the second character they start, again they send the a start of that character and a stop of the next character. But in the synchronous transmission, only first few bits are required for synchronization. If both are fully synchronized, then continuous data will be transmitting between the sender and the receiver. But whereas asynchronous mode, for each character the data has to be, some information has to go to the receiver. This is the first character, this is the second character, this is third character. Whereas in synchronous, no, only in first beginning we have set of characters, and then the flow of information will be there always. Now what we have, the communication protocol that controls asynchronous transmission, that is the ASCII code. So basically what I was talking about in ASCII, basically we talk about asynchronous mode of transmission. So this is example, this is one character now. So overheads are much more higher than the synchronous mode, right? So this is what we call them the asynchronous mode of transmissions. Now, now let's talk about the what we call them different type of circuits are available. What we call them the dial-up lines. We have a lease line services. We have a packet switch networks and so on. So these are the, and then finally one is called ISDN. Just briefly I will talk about here is the what is called the dial-up lines. And for example, most of you are connected with dial-up first, right? It is not available throughout the time. For example, we have a lease line services, means all the 24 hours I can connect to any place I want. But in dial-up first you have to make a call. If the call is through, then only you can make a connections now. Lease line is something different, means it is available just like you have STD, anytime you can make a call and get your work done. Same thing what we call them lease lines now. What the point is, let's examine one of them very quickly now. Here subscriber, let's talk about the switched dial-up lines. Here subscriber sends routing informations that you dial the number. First you have to dial this number to the network which connects them to the receiver, then follow this with the informations. So first you have to give some dial-up information, then only you can connect. When you get the acceptance, then only you can send the data. So this is called what we have in the lease lines, the permanent non-switched end-to-end connections. There is no need to send the routing informations along with the data. If you have a lease line service, you simply don't make a telephone call directly. You can connect to any site which you want. That is the difference between lease line. But again, nothing is free of cost. You have to pay money accordingly now. So in lease line, you have to pay much more than what you pay in the dial-up services now. Suited for high volume, right? Because the cost is very high. You have to pay a lots of prices for it, and right. So basically, when you are going for the lease line, you first have to decide the price factor now. Now packet switch network, I have told you in the beginning that there are two types of techniques, what we call them the packet switching and circuit switching. The two types of technique we used in data transmission in wide area network. Now the one is simply is the circuit switch network is very similar to telephone network. So when I have to talk to somebody, I have to establish a connection. Once a connection is established between the sender and the receiver, then you can talk uninterrupted. But in the packet switch network, what happens is data is packetized. So there is a protocol which will convert all the informations into the packet form. Then packet will go to the next node, which will be stored for a time, for temporary period. Then it will be forwarded to the next node and so on. So when we say circuit switching, it is basically the fixed path is laid out before sending the data. Then one can send data as many as time as want. But in packet switch network, whole information is converted into the packets, and then packet is sent from one node to another node and so on. So this way basically, let me conclude that we have finished the data communication related issues. Whatever problems you have related to today's presentations, please ask the question through email, and next time when I am joining, I will be answering all your calls. Thank you very much.